We use AI tools for just about everything these days. But it turns out they have a surprising environmental footprint. Behind all our digital chats, there's a very real, very physical resource being used up: water. So today, we're going to uncover AI's hidden thirst. So let's just start with a question that sounds kind of weird, but it has a surprisingly real answer. When you ask an AI, say, to help you write an email, how much water does it actually drink to do that for you? Believe it or not, the answer can be about this much: a standard bottle of water. That's a real physical amount for something we just think of as, digital, happening somewhere out in the cloud. Yeah, that's a real world cost for just one short conversation. And that water isn't being splashed around inside a computer. It's being consumed by the massive physical buildings and power plants that make AI possible in the first place. So, how in the world can a digital tool have such a real thirst? To get that, we have to look past our screens and into the giant physical systems that actually run the AI. And this really gets to what Professor Leo S. Lois is talking about here. Being AI illiterate isn't just about using the tool. It's about seeing the whole picture. It's about getting the real-world impact so we can figure out how to balance all this amazing innovation with, sustainability. The water use really comes from two main places, and they're both totally invisible to us as users. It's not just one thing, it's a combo of cooling the machines and then powering them up.
Okay, so check this out. AI's thirst actually comes from two hidden streams. First, you've got the direct, on-site water use for cooling these enormous data centers. But then there's the second, indirect use: all the water that power plants drink just to generate the insane amount of electricity those servers need to run.
And this is why the specific power source is so critical. I mean, a data center running on wind or solar has a tiny off-site water footprint, but compare that to one powered by a traditional coal plant or even a hydroelectric dam, it's a whole different story. But here's the thing: the total water footprint isn't some fixed number. It changes a lot based on a few key things: where the data center is located, what time of day it is, and yeah, even which AI model you're using all play a huge part. Geography and even the time of day are massive factors. A query that gets processed in a cool place like Ireland might use hardly any water for cooling. But that exact same query processed during a summer heat wave in Arizona, well, that needs a ton of water for evaporative cooling just to keep the servers from literally melting. And it's not just where the AI is running, it's which AI you're using. The design of the model itself is a huge deal. An older, clunkier model can be way thirstier than a newer, more efficient one. Okay, so let's actually dive into this and see how you can estimate this footprint for yourself. It's surprisingly easy, and you definitely don't need an engineering degree to do it. It's really just a simple three-step process. You just need two numbers: how much energy a single query takes and how much water is used to create and cool that little bit of energy. So for step one, some independent analysis gives us these energy numbers for different OpenAI models. And just, wow, look at the huge difference between GPT-5 and the much more efficient GPT-4o. Then for step two, researchers give us this range, which covers both cooling and power. We're just going to use the higher number, 2.0, to stand in for a pretty typical data center. And finally, for step three, we just multiply those two numbers together: the energy used and the water factor. Simple as that. So for a medium-length question to the less efficient GPT-5 model in a typical facility, that comes out to about 39 milliliters. That's enough to notice for just one single digital click. But now, get this. For the more efficient GPT-4o, the footprint just plummets to 3.5 milliliters. That's more than a 10 times drop. It just goes to show you how much the model's design really matters. Okay, so these little numbers are interesting, but what happens when we zoom out? What does this all mean when we scale it up? We're talking about billions of prompts hitting these systems every single day. Right. When you multiply by all those daily prompts, the numbers get pretty significant. That huge range for GPT you see there, that's because we don't know the exact mix of models people are using, from the thirsty old ones to the super efficient new ones. Google's number for Gemini, on the other hand, kind of shows what's possible with really optimized systems. Now, to really put this in perspective, let's compare it to something we're all familiar with. On the left, you've got the high-end guess for all daily GPT prompts. But then, look all the way to the far right. That's the amount of water used by Americans every day just to water their lawns and gardens. So the takeaway here isn't that AI's water use is nothing. It's that right now, it's still just a drop in the bucket compared to other massive uses like lawn care. That doesn't give it a free pass, but it helps put it in context. The real concern is just the explosive rate of growth we're seeing.
So, what's the bottom line here? The point is not to stop using AI. It's to be aware that there's a hidden cost. And knowing this empowers us as users to push for more efficiency and more transparency from the companies building these incredible tools. And that really leaves us with a final thought to chew on. As this technology gets deeper and deeper into our lives, its demand for resources is only going to grow. The real challenge is going to be making sure that our understanding of its impact and our ability to manage it grows right along with it.